When working with GIS data, a common challenge is integrating data sets from multiple sources. Often, the data you want to use has different geographic boundaries. For example, a neighborhood boundary from the 1930s and a modern census tract boundary may all describe the same place, but they don't perfectly align. This raises a question. How can you compare or combine information if the geographic boundaries don't match? In GIS, there are a few ways to approach this issue. The first is a spatial join. A spatial join appends information from one layer to another based on where features meet in space. If a census tract falls within a neighborhood boundary, the neighborhood will inherit the tract's attributes. The resulting layer will have the spatial extent of the initial neighborhoods, only now contain attributes for both layers. It is common for a single homeowners loan corporation, or HOLC, neighborhood to overlap multiple census tracts, each with different values. A spatial join won't work well because in this case, you want to summarize all the pieces that fall inside the neighborhood. For this situation, you would use a tool called Summarize Within, which will give you everything inside the boundary. You can choose to find the sum or average of various attributes within the boundary. Summaries are more often used to discover where people live, rather than assuming everything inside a census unit contributes equally. GIS does this using what is called population-based apportionment, which distributes demographic values into the boundary based on population estimates, not just area. Together, spatial join and summarize within allow you to translate and combine data from one geography to another. This is essential for comparing information across space, building models, and understanding how different processes interact. In redlining, you may want to understand how conditions vary across the original A, B, C, and D HOLC neighborhoods. However, modern demographic data, like income or vacancy, is stored in census tracts and block groups, which don't match the 1930s boundaries. So to make a fair comparison, you must bring those values into the neighborhoods. This could be done using analysis tools in the following workflow. Intersect the layers, calculate overlaps, apportion the values based on population, and summarize them for every neighborhood polygon. To facilitate the process of adding demographic variables to data, you can use the Enrich tool. The Enrich tool automates the entire spatial reasoning process. In this example, you want to add variables for housing vacancy to the redlining neighborhood polygons. The current attribute table contains the following attributes. Note that no vacancy variables are present. Next, go to the Analysis button and locate the Enrich Layer tool. When you are setting up the tool parameters, you identify the input layer, which in this case is the neighborhood polygons. The layer contains the geometry you want to preserve in the output. Then you choose the enrichment variables. When you click this button, you are taken to a data browser window where you can search for and choose from thousands of demographic variables. You can search based on keywords or use the categories. When you select the variables that you want, click Select, provide an output name, and estimate the credits so you know how many credits are being consumed when the tool runs. When it runs, the tool identifies the smaller demographic units inside each area, uses population-based apportionment to estimate the values within it, and returns a version of the layer that contains the demographic attributes that you want. In other words, enrichment simply carries out the GIS operations of spatial join, summarize within, and population-based apportionment, all within one tool that adds demographic variables from the cloud. Once the data shares a common geography and contains all the information you want, you can begin exploratory analysis, mapping differences, comparing grades, and identifying the spatial patterns that reflect the long-term impacts of redlining.